Hello and welcome everyone to today's coding challenge. Today we are going to discuss a question on LeetCode. This is question number 1730, shortest path to get food. This is a premium problem, and this problem states that you are starving and you want to eat food as quickly as possible, and you want to find the shortest path to arrive at any food cell. Basically, we have given a m cross n matrix named as grid that contains different types of cells. A star is our location, and there is exactly one location of our cell, and a hash is a food cell, and there can be multiple food cells present in any matrix. A O represents the free space where we can travel, and a X represents an obstacle and we cannot travel through these cells. We can travel to any of the four adjacent directions: north, south, east or west, until and unless there are no obstacle present in our path, and we have to return the length of the shortest path for us to reach any food cell, and if there is no path exit we have to return -1. Let us look at example number 1. The given matrix looks like this. Our location is here. We can travel through this cell and can reach the nearest food cell in 3 seconds. This takes 1, this takes 2, and at third second we can reach at the food cell. Also we can travel like this and this also takes 3 seconds, and we can travel like this path, and we can see that the minimum value to reach the nearest food cell will be 3. In example number 2, we cannot move to any food cell because there are obstacles all around our location, so we cannot pass through those obstacles to reach any food cell. So in this case we have to return -1. And in example number 3, we can travel through like this and reach the nearest food cell in 6 steps: 1, 2, 3, 4, 5 and 6. We can also reach to the other food cell, but that takes more time, so we have to return the length of the shortest path, so this will be 6. And also in example number 4, we will take 5 seconds to reach any of the nearest food cell. Now what could be the approach to solve this? Let us first visualize this and then we can code. First of all, we have to visualize that if we are on any cell, suppose we are on R, C cell, we can move to any of the 4 connecting adjacent cells. And what could be the coordinates for those connecting cells? This is up, down, left and right. Now if we want to move to the upward cell, the coordinates for that cell will be row -1. That means the row is decremented by 1, but the column is same. As we can see, if we want to move to the right cell, the row is same but the column is incremented by 1. That means this is R, C plus 1, like this. Now if we want to move to the downward, the row is incremented by 1. That means this is R plus 1, but the column is same. And for any left cell, the row is same but column is decremented by 1. So this is R, C minus 1. We can mark these coordinates through -1, 0, 0, 1, 1, 0, and this is 0, -1. Now what we are doing in this solution is we will make a queue that contains pair of integer, and in that queue what we are going to push the coordinate of our location with the time 0. That means if suppose we are on I comma j and the current time is 0, so we have to push coordinates of I comma j in our queue. Now what we are going to do, we are going to do a BFS from our location until and unless we are going to find any food cell. Now for any BFS technique, the adjacent cells can be traversed in 1 second. All the 4 adjacent cell can be traveled in 1 second. That means this cell can be traveled in 1 second. Either this man can go to this cell or this cell. So both of these two cells can be traveled in 1 second. Now from this cell, either it can go to this cell or this cell. So this cell and this cell will be traveled in second. After moving to this cell, it can reach this cell in the 3rd second, or through this cell the person can reach to the food cell in 3rd second. So we have to return 3. Now we move on the queue until the queue gets empty. If the queue gets empty and we are not getting any food cell, so we have to return -1 in that case. Now let us code this and check what we are going to do. Also we have to take care that if we visit a cell, so we have to mark that cell as previously visited cell, so we can avoid the revisiting of that cell. Suppose if we are here, we already visited this cell and this cell, so these cells will be marked as visited cell, so we have to avoid revisit these cells. So we can make a boolean array to avoid the revisiting. Let us first take the dimensions of the matrix given to us. Now let us make a queue that contains pair of integer this queue will contain time and then coordinates. Now let us make a boolean array named as visited that is of the same size of the matrix given to us. All the cells of this boolean array marked false initially, and now run a loop over the matrix to find out the current location coordinate of the person. If the grid of I comma j is star, that means we find out the current location. Now we first mark our I comma j as visited, so we can avoid to revisit this cell again from any adjacent cell. Now after doing this, we have to push these coordinates with time 0 inside our queue like this. Now what is the main logic? The main logic starts from here. We move on queue until it gets empty. take the dimensions and then pop out the current pair from our queue. Now after popping out the current pair, we have to check that whether we are on any food cell or not. That means if grid of R comma C is a food cell, and for food cell we have to check whether grid R of C is a hash or not. So we can check. If it is a hash, then we have to return the current time. If it is not a hash, then we have to move on the adjacent 4 directions of R comma C. Now the new R will be the previous R plus dir of x of 0, and the new C will be the previous C and dirs of x of 1. So this will give us the new coordinates. Now we have to check that whether these directions are within the range of this matrix or not. That means if nr is greater than equals to 0, also nr should less than m, and nc should greater than equals to 0 and nc should less than m. Also this current coordinate is not previously visited. Also this current coordinate should not be any obstacle or our previous location. So this should not be any obstacle. If all of these conditions get satisfied, we will mark the new coordinates as visited, and we have to push these coordinates with time plus 1 inside our queue. After doing this, we finally ensure that if we are able to reach any food cell, then the right time will be returned, and if all these coordinates will be traveled and we did not find any food cell, in that case we have to return -1. Only then we have to return -1. So let us run this and check if it is running fine. It is running fine. So let us submit this and check if it does passes all the test cases or not. It is passing all the test cases, and this is a pretty good solution. So do like and subscribe to this YouTube channel if you are getting the concepts from here, and if you have any other better solutions for this problem, please do comment, and please like and subscribe. So thank you so much guys, and keep watching this